Okay, we're going to have another look at another example about plotting using intercepts. In this example that you have in your exercise book, you start off at a position at 6:30. You're given a DR position, and you have a sight of Venus at that time. The vessel then proceeds for 3.5 hours on a track of 223 degrees for 57 miles. Then at that time, 10 o'clock, you get another bearing. Well, this is the sun this time, and the intercept was 0.9 towards bearing 126 degrees. So you have two intercepts 3.5 hours apart. So how do we solve this problem? Okay, well, what we do a little sketch to explain what's happened. This is our DR position at 6:30, and we're not going to plot our intercept that we got at that time there. We're just going to put that to one side at the moment. So that's where we are at 6:30. We then proceeded on a course of 223 at 57 miles to a DR position here at 10 o'clock. Then at this DR position we observed the sun, and the bearing was towards at 126. So at a bearing of 126 we had this intercept there towards. What we then do is plot the intercept that we got at 6:30, which was Venus at 265, and then where the two cross, that is where we will be at 10 o'clock. So all we've done, we've transferred the intercept from 6:30 through the 10 o'clock DR position. So that's what the sketch would look like on the graph. You don't need to, this won't be on the graph, because what we need to do is plot between 6:30 and 10, the 223 degrees at 57, by plain sailing methods. We don't plot that, we do plain sailing to calculate our 10 o'clock DR. Then we put the 10 o'clock DR on the graph paper and plot the two bearings. So what we'd do, we'd use our formulas for plain sailing. We've gone 223 degrees at 57 miles, 6:30 till 10. We calculate our D-lat, calculate our departure, calculate our D-long using the plain sailing formulas. By doing that, that will give us our 10 o'clock DR position. So what we do, this is our 10 o'clock DR position we've written down on our exercise paper. On the graph paper here, this would be our DR position at 10 o'clock. And what I've done, I've plotted the bearing of the sun, which is 126 degrees towards at 0.9. Then I've drawn my intercept there. Then I've plotted Venus, which was 265 at 3 miles towards, and again plotted my intercept position line, and that's where we will be at 10 o'clock. It's useful on the graph paper where you've put your DR to actually write the DR position to ensure that you run your bearing lines from the right position, because if it's not clear here, you may run it from here or here. So make sure you put DR there. And what we do the same procedure as before. We measure our D-lat, measure our departure, and then we can calculate our fix. Now, measuring the D-lat, you can either put your dividers on the position up to the line, then go to your scale, or you can simply put dotted lines up each side and then measure appropriately. It doesn't matter, they're both as accurate as each other. So that's how we would draw the two intercepts, just as we've done before. But the key difference with this problem, we've actually run, we've written down on note paper, we're here at 6:30, we've run a course here to our 10 o'clock DR, and then we've plotted. Providing we know this course, 223 at 57 miles, we can do this. This is no problem. And all we've done, we've plotted the 6:30 intercept at the 10 o'clock DR. And that's enabled us, by using the intercept that we got at 10 o'clock, that's enabled us to find our fix at 10 o'clock.